Okay, and we are recording. Welcome. Today, well, it's tonight really. Tonight I'm going to be working on, here we go, we've shared my screen, the 2015 HSC examination questions. I've downloaded them from 2014, and they are quite a pleasure to go through. You may find that funny. Let's just look at the first 10 multiple choice questions, and we'll work on the extended questions at another time. So we'll see how we go. Question number 1, what is 0.005-23359? Written in scientific notation, corrected 4 significant figures. Well, 4 significant figures simply means 4 digits excluding the initial zeros. So I'm going to have to move this decimal place over. 1, 2, 3. So that means whatever number I've got, it is times 10 to the negative 3. And I want 4 digits, and I'm going to look at the 5th digit and see whether that helps us round up or not at all. So I'm going to have 5.23. What happens here? 4. We round that one up. So my answer is 5.234 times 10 to the minus 3. Lock it in. What do we got? D. Question 1, D. Whoops, wrong direction. I usually set it up the other way. 1, D. Question 2, what is the slope of the line with the equation 2x minus 4y plus 3? New page. 2x minus 4y plus 3 equals 0. I'm just going to check that's correct. Yep. Let's rearrange it into the standard form. I can easily read the gradient from that standard form. In fact, I'm not even going to put 4y there. I'm just going to put y here. I'm going to divide that by 4 and divide that by 4. And I'm going to go x divided by 2 plus 3 on 4 equals y. This is good enough as mx plus b equals y. You may also know this as y equals mx plus b. In either case, that m, the coefficient next to the x, tells us our gradient. And right now, there is an invisible 1 right hanging out in front of that x, 1 times x. So my coefficient is going to be 1/2. 1/2 is C. So I'm going to lock in question 2, C. Come on. Better go this direction. Question 2, C. Next question, question 3. The first 3 terms of an arithmetic series are 3, 7, and 11. What is the 15th term in this series? We've got to know how arithmetic series work. How do I clear this? Yes. Arithmetic series. We have an initial term, we'll call it k, and then we just add on another number. So in this case, it was 3, 4, 3, 7, 11. 3, 7, 11. So we've got 3, that's plus 4, that's plus 4 again. The next term is going to be plus 4. So we take the initial term and we add 3 plus n minus 1 times 4. So as n minus 1 times d. We'll call it d, the distance between each term. 15. 15 is what they wanted. The 15th term of this series. So I'm going to need a calculator. I'm going to put 15 where my n is. 14 times 4 plus 3 equals, it'll help if I turn my calculator on. 14 times 4 plus 3. 59. 59 is A. Check it. 3, A. Next question. The probability that Mel's soccer team wins this weekend is 5/7. The probability that Mel's rugby league team wins this weekend is 2/3. What is the probability that neither team wins this weekend? Neither team. We take the probability that the soccer team does not win and multiply that by the probability that the rugby team doesn't win. We've got 2 on 7 times 1 on 3. That gives me 2 on 21. 2 on 21, A. Question 4, A. Question 5. Using the trapezoidal rule, with 4 subintervals, which expression gives the approximate area under the curve y equals x e to the x between x equals 1 and x equals 3? I like this question. New page. Bam, bam. I don't expect any student really to know this. This graph, well, I use it with my students. This graph looks like this. It is not, that's going to be a straight line over there. It is not this sort of common function that you're used to seeing. And we're using the trapezoidal rule. It is effectively looking for the area, an approximation for this particular area here. We have to remember the formula for the trapezoidal rule. There's no way around it. So the formula is something along the lines of exactly this: delta x onto, I'm going to put it a different way because otherwise it could be confusing. Let's call this b and this a, if that's okay. So I'm going to go b minus a divided by the number of subintervals and divide that by 2. It's complicated, but that's what it is. And then we go the function. How many subintervals do we have? 4. 4 subintervals. Watch this. If I cut this into 4 subintervals, there's 2, there's 4. I've actually got 1, 2, 3, 4, 5 values. So I need 5 values here. fx0 plus, and here's the trick. We've got the Simpsons rule and we've got trapezoidal rule, so don't forget them, the difference between them. 2x1 plus 2 fx2 plus 2 fx3 plus, there's no 2 coefficient here, fx4. That is trapezoidal rule. Okay, b is, this is 3, I think. This is 1. I don't think, yep, I'm going to change that. E to the x times x. That's that function equals y. So let's do this. We got b is 3. 3 minus 1 is 2. Divided by how many subintervals? 4. We've got 2 over 4. 2 over 4 is a half. 1/2 divided by 2. Let's do it like this. I mean, 1/2 divided by 2 is 1/4, but 1/2 divided by 2, or we could think of it as 2 on 1. 1/2 times 1 on 2. We use the little flippy flip rule. Then we get 1/4. So my coefficient at the front here is 1/4 bracket. Now we got to start getting real. This value over here is a 3. This value over here is a 1. Obviously, this one is 2. This one is 1.5. This one is 2.5. Let's do it. First value I'm putting in is x equals 1. So I got 1 times e to the 1. First value is e here. Plus 2 times 1.5. That's 3. E to the 1.5. 3 e to the 1.5. Next is 2 times, x is 2. 2 times 2 is 4, e squared. 4e squared. We're at 2 times 2.5. That gives me 5e to the 2.5. 5e to the 2.5. Plus, no coefficient here. That's 3. So I got 3e to the 3. 3e to the 3. Let's cross our fingers. 1/4. 1, 3, 4, 5, 3. 1/4. 1, 3, 4, 5, 3. Check those coefficients. 1.5 to 2.53. Looks good. I'm going to go with 5b. 5b. What is the value of the derivative of y equals 2 sine 3x minus 3 tan x at x equals 0? Well, that looks like a good question and not too tricky either. 2 sine 3x minus 3 tan x. what was it? 2 sine 3x minus 3 tan x. 2 sine 3x minus 3 tan x. We're finding the derivative at x equals 0. Well, we're actually finding the inflection points. So y equals this. We're going to go y prime, or you could call it f prime x, or you could call it dy dx, whatever you like. Derivative of the inside, this is a chain rule here. Chain rule. Derivative of the inside is 3 times 2 is 6. 6. Now we take the derivative of sine is cos 3x minus the derivative of tan is sec squared x, also known as 1 over cos squared x. So we've got 3. Let me put it like this. 3 over cos squared x. And we're saying x equals 0. I think that's right. Yep, at x equals 0. So check it. This is what cos looks like. Bam, bam, bam. So at sec cos. Yeah. So at x is 0, cos is 1. So we've got 3. Sorry. This becomes 1. This also becomes 1 on the bottom there. So I'm going to go 6 minus 3. Answer looks like it's 3. C. 6C. Question 6. C. Yo. 7. The diagram shows the parabola 4x minus x squared, meeting the line y equals 2x at 0, 0, and 2, 4. Cool. Which expression gives the area of the shaded region bounded by the parabola and the line? I don't even think I've got to draw this. We're just taking this parabola, this one here, right? And we're subtracting the line. Do I need to draw it? I'll just draw it quickly. There's a parabola. Here's your x-axis. Doesn't matter where the y-axis is. Here's a line. Whoop. Okay, and we're just going to take, say, from here to here. So we're just having everything under that parabola curve, subtract everything under this line, and that's going to give us this particular shaded region here. So let's go. 4x minus x squared, subtract 2x. That just gives us 2x minus x squared. Take the integral of that between the x values of 2 and 0. 2 on the top, 0 on the bottom. Yep. It's obviously not C or D. But I already forgot what I said. 2x minus x squared. That's what the answer should be. 2x minus x squared. I'm going to go with B. What question is it? We'll find out. 7. 7B. Okay, 8. The diagram shows the graph of e to the x, 1 plus x. They got another one of these very nice functions here. Cool. How many solutions are there to the equation e to the x, 1 plus x, equals 1 minus x squared? Oh, what a great question. Basically, we just put these two graphs on top of each other and see what happens. 1 minus x squared. 1 minus x squared. So this has 1 point, 1 solution, x equals 1. So it's going to be here, and it's going to go up like this. Whoop, whoop. We've got this curve here. It goes like whoop, something like this. It looks like there's just going to be one answer here. Any tricks to this question? Do you have any tricks? Yes, there is a trick. I wrote it down wrong. It's 1 minus x squared, not in brackets. 1 minus x squared. Let's do this again. 1 minus x squared. Okay, this is a different situation we got here. This is this. Cool. Okay, and if the graph is doing this, look, 1, 2, 2 solutions. Lucky I checked. Lucky I checked. Okay, lock in 2, C, 8, C. 8, C. 9, a particle is moving along the x-axis. Look at that. The graph shows its velocity v in meters per second at time t seconds. It's moving along the x-axis. Velocity is decreasing. And then it gets negative. Okay, it's slowing down. Look, velocity gets less and less and less and less and less until it's velocity in the other direction. When t equals 0, the displacement x is equal to 2 meters. Okay, cool. What is the maximum value of the displacement x? Oh, that's an interesting question. How are we going to do it? When t equals 0, the displacement x is equal to 2 meters. Okay, I want a displacement function. I am going to take a velocity function. Cool, I got a straight line here, so I can get velocity with respect to time. It's going to be 8. It's going to be 8 minus 2x. Yeah, 8 minus 2x. I'll show you how to do that. And then 8 minus 2x, find the integral of that. That gives me the displacement function. Use these initial conditions. T equals 0, displacement is 2. Find my k. And then find the maximum, what is the maximum value of the displacement? And then there's going to be a maximum value there. Okay, obviously you can do it that way, but is there an easier way to do this? Is there an easier way to do this? Okay, an integral just takes the area under the curve, right? So this is a triangle. We don't have to do no integration. We can just take the area of that triangle. And that will give us the displacement. We take the area under that triangle, that will give us a displacement before the particle starts moving in the negative direction. So that necessarily is going to be maximum displacement. And then, since we know the initial displacement is 2, we just add that. Okay, let's do it that way. I want the area of this triangle. I've got 8. It's 8 high, 4 across. Divide by 2. So 8 times 2 is 16. 16 plus 2, 18. I'm going to go with D, 18, 9. 9, 18. I better show you guys how I did that. But let's write that down. 9. D. Is that D? 18 is D. Cool. Okay, there's 2 ways to do this. Okay. One way is to figure out this function. It started at 8 there, and it went to 4, 0. This is 0, 8. So I could recognize this as a straight line. It's going down with a gradient of -2 going down, and it's going down twice as fast as it's going to the right. So this is obviously y equals -2x plus 8. 8 being where it crosses the y-axis, x equals 0. So I can take the integral of that. Okay, let's take the integral of that. Integrate this function. That equals -x squared plus 8x plus k. Okay, and then the initial displacement when, oh yo, this ain't working. Is that x? This is t. This is t, and also that y. This is velocity. This is the velocity function. We're talking about velocity versus time here. So we could call it velocity as a function of time equals this function that I've just written out, -2t plus 8. Okay, so everywhere we've got an X, just imagine there's a T, because it really should be T. I apologize. So we've just gone from velocity to displacement. I'm going to call it D in this case. D equals. Initial displacement is 2. When these are T's, are 0. So 0 plus K equals K. So now I know K equals 2. So my displacement equals negative T squared plus 8T plus 2. And if I wanted to find the maximum here, I can't believe this. I'd find the derivative. We're going in circles. I much prefer my way that I did before. Plus 8 equals 0. Find when this is 0. This is the maximum. Negative 2t equals negative 8. T equals 4, which was obviously going to be where it crosses there. And then just substitute t back into your displacement formula. Who would want to do it this way? I'm sorry for taking you through this way. Well, we're here now, so let's just do it. Negative 14, negative 16, yo. 8, 16 to 4, 32, plus 32, plus 32. Oh, this is negative 16, plus 2. So, and that is 18. There's one way to do it. The better way to do it is to recognize the integral is just the area under the curve. So we go 8 times 4 times a half, 8 times 4 times a half, and that is 16. And but 16 plus a constant. We know the initial condition was that the displacement was 2, so 18. Okay, that's how I did that. Let's never talk about that again. 10. The diagram shows the area under the curve y equals 2 on x from 1 to d. Cool. What value of d makes the shaded area equal to 2? Okay. The derivative of this looks, the integral of this is a log function. We've got to recognize that. Y equals 2 on x. If I take the integral, let's not be so messy here. The integral equals 2x, 2 log x plus k. We're talking about from d to 1. Since we're talking about definite integral, I don't need my k. D to 1. So we're going to evaluate this. 2 log d minus 2 log 1. E to the power of what equals 1? This is really asking the question. E to the power of something here equals 1. Well, that question mark is a 0. That means this term is a 0. That means this whole term is a 0. So get rid of that. Yeah. 2 log d equals, what was the answer? It said, what is d to make the area under the curve equal 2? So log d equals 1, and then e to the power of what equals 1. Hang on a second. E to the power of 1 equals d. E to the power of 1 equals d. It's tiring. Not tiring. I'm tired. It's like 11 at night. But anyway, so d is e. D is e to the power of 1. I'm going to go with a. Yep, confident enough. Let's go with a. 10a. 10a. Check our answers. D, C, A, A, B. D, C, A, A, B. I'm going to tick them, make me feel good. Okay, we got C, B, C, D, A. C, B, C, D, A. Woo-hoo. Crowd goes wild. Okay, that was the first 10 multiple choice questions of the 2015 HSC exam paper. I hope you enjoyed. I'll do the longer extended questions soon. Thank you. Stop share. Stop record. Goodbye.